Alright guys, welcome to 40-Day Pilot Flight Academy. Today I will conduct the class of multi-engine and we're going to discuss about the VMC. Okay, the VMC is the calibrated airspeed at which that when critical engine is suddenly made inoperative, it is still possible, number one, to maintain control of the airplane when the engine is still inoperative. Number two, maintain straight flight with the same airspeed or the same speed based on the FAA definition, right? The same speed and the angle of bang no more than 5 degrees. That's the VMC. So any airplane, the multi-engine, the twin airplane, as we know, a lot of multi-engine airplane, like 737 is multi-engine airplane. Right? The Piper, Seminole, Seneca, 421 is multi-engine airplane. But what makes that different? What makes that different is the regulation that certified the multi-engine airplane. If you're talking about the Seneca or Seminole, Duchess, that categorized as light twin. So all light twin engine is certified under Part 23, right? 23? Is that correct? Check it. Part 23, 149. That's about the VMC. Right. So if you're flying A320, Citation, Gulfstream, whatever, all the jet stuff, or maybe King Air, ATR, they are air transport category airplane. They are certified under Part 25. So let's open Part 25. What's 25 here? Do we have 25 here? Not here. Okay, I'll show you later. MAR, see, 23, 25. This is not a part of this, but okay, I'll show you later. But you know, the Part 23 and 25. If you're flying under Part 25, the certification of the airplane, the air transport category, the difference is all the numbers for that airplane is guaranteed. So you should fly the numbers. Let's say you fly the V2 and at specific numbers based on the current weight, okay, that must be guaranteed. When you follow that, you will never get any deviation for like lower performance than what is promised in the book. But the Part 23 is recommended, it's not guaranteed, but you should follow that. So let's say the blue line, VYSE, right? Or you know the blue line, okay? That's a safety speed for single engine, okay? When your another engine is inoperative. So what happens if you follow that? It's recommended by the company, by the manufacturer, that if you follow the blue line, you're not gonna dive like that. So at least you will maintain straight level, and you are not descending, or even you can gain single engine climb rate. Okay. Now, what happens if one engine is operative? Then you have VMC. So the VMC is minimum controllable airspeed. It means it's all about your rudder effectiveness, your rudder authority. When you lost one engine, okay, there is a 4 aerodynamic principles. You have P factor on the critical engine, right? You have accelerated slipstream with the induced airflow. What we don't want to happen if the airplane it moves like it stalls with the single engine. So the VMC, when your rudder is no longer can maintain the yaw effect. So let's say the airplane moves like this to the left. You need to push right rudder.
Yes.
That engine, that rudder. So left rudder is, you don't use the left rudder, so you kick right rudder to make the airplane yaw back to straight. But what happened when you push all the way at the end of the rudder and the airplane still cannot back to the straight?
Rudder authority.
The rudder is not effective. The rudder is out of its authority. So that's what we call the VMC. So the VMC, normally we call that the red radial speed, right?
Yes.
You have red radial on the airspeed. It means that's the minimum. If the airspeed passes the red and you don't do proper correction, what's going to happen? Your rudder will no longer can
Effective.
overcome the yaw. That's gonna go. The airplane, let's say this multi-engine, is gonna go like this and roll, and you will go to the flat spin, which is that I don't believe that you can recover. Flat spin is like this.
Yeah.
Okay? It's not recoverable. You're gonna die. That's why we're really concerned about the VMC. So every airplane under Part 23, they certify the airplane and they test the airplane. Where's the limit? Where's the limit of the airspeed that the rudder will no longer be effective? Alright? Can the VMC's airspeed increase?
Yeah.
Yeah. So the VMC is not only the red line. It can increase, it's just like a stall speed. That is the problem. We always want the VMC lower. We always want the VMC lower. We never want the VMC getting higher. How to test the VMC certification? So the company, the manufacturer, certified the airplane. Let's say you're going to DATSUS. So DATSUS is being certified and measured in the worst condition. They want to see the VMC limit of the airplane. You know, the worst condition. So when you test or you will show the VMC demo on your check ride, think, I want to make the VMC speed higher.
Oh.
Right? Worst condition will make the VMC higher. I mean, I will show to my examiner, I will set all the configuration for my airplane to make the VMC higher. So what are they? That's the things. So why do we have all the lists like the names? You have combat, cancelable, or whatever is that? I'm using, I have my own list. I think this is good too. So principally, whatever list you want to use, the idea is the configuration must be at the worst situation that will drag the VMC higher. Okay? So I use this. You can use combat or whatever you want, as long as you know what are you doing, right? P, W, P, D, G, G, C. It's really easy. And in here, you should know what makes lower VMC. If you know how to make lower VMC, it's better because we always want to have lower VMC.
Yeah.
But on the check ride,
Higher.
VMC to show that we can recover from the VMC. Of course, when I teach my students, I always teach them how to make the VMC lower. Okay? So let's talk about the CG. So this will be CG, this will be bang, this will be weight, this will be power, density, drag device, jet prop, critical engine. Okay? So these two will connect. Related. So let's talk about CG. How to lower the VMC? FCG or forward CG?
FCG.
So this is our plane. This is the rudder. This is the CG. Or it can go for. What makes the airplane? Okay, this is all. This is the illustration. So we have CG here. So it means this is aft CG. And we have here forward CG. Which one from the rudder is easier to turn the airplane?
Forward.
Forward, because you have longer arm
Yes.
compared to this, right?
Yeah.
So this arm and this arm compared to this arm and this arm, it's just like a teeter-totter.
Mhm.
So it's easier for me to move the airplane like this because we have forward CG, and harder if we only have like this kind of arm to move the things.
Yeah.
Just like if you open the oil in the Cessna, if you have a longer handle, it's easier for you to turn. Okay? So if you want to lower the VMC, put the forward CG. Okay? And you can see here, forward CG, decrease VMC, aft CG, increase VMC. Of course, higher VMC here, aft CG, right?
Yeah.
How about the bang? Why need to care about the bang? How to lower the VMC? 5 degrees or more, right? How about here? No more than 5. Shallower bang. Why? Why do we care about the bang? See this airplane? Why do we want to raise the depth instead of talking about the zero side slip? Why? When
To minimize the drag.
not to minimize the drag. Remember, why the airplane turn?
Horizontal component of lift.
Good. So this is vertical component of lift, and this is your load factor, right?
Yeah.
And you have this.
Horizontal component.
This is horizontal component of lift. Okay.
Yeah.
If you bend more,
You put more horizontal.
you put more horizontal component of lift, then it helps you to overcome the yaw. So now you have operating engine here, you have that engine here. Where's the asymmetric thrust direction? Right,
Right.
right?
Yeah.
Then you want to kick your left rudder to make it like this.
Yes.
The more you kick the rudder without you put a raise to that or you put bang, you will have you have side slip.
Yeah.
So how to reduce the usage of the rudder or helping the rudder? The idea is how to help the rudder. Use the bang, use the horizontal component of lift to give you more power
Contract.
for the rudder to counter
Yeah.
the asymmetric thrust. So the bang, the more the bang, the better. Actually like that. So if you fly later for the VMC demo, the bang should not more than
5 degrees.
Now how about the weight? The more the weight, let's say this is the weight, right? Okay? See? The more the weight, let's say this is 3,000 pounds, and you put maximum takeoff weight. Okay? The more the weight is here, that's the weight resultant. Of course, load factor more, and you have more. You need more lift to overcome more weight, then more horizontal component of lift. Okay? Understand? So that's the relation between bang and weight. Power density. How to make the VMC higher? How to make the rudder has less effectiveness? Takeoff power.
Full.
Full power. So power, do we have that something there? No? Next page, please. See that? No band, increase VMC. Band 1 to 5 degrees, decrease VMC. More than 5 degrees, decrease VMC, right?
Yeah.
Windmilling propeller, increase, feather propeller here. Do we have next? No? No. Okay. So the power takeoff configuration. Let's say here, windmilling propeller increase. So takeoff configuration, that will be max power. Let's talk about the power first. The more the power you have, what's gonna happen? The more asymmetric thrust you have.
Yeah.
That's why when you shoot ILS approach with a single engine, when you're a little bit high about the glide slope, then you reduce the power to become equal, then the asymmetric thrust is reduced.
Yeah.
That's why if you descending like this, idle power is just like same. It's just like normal engine. Because less asymmetric thrust. So the more the power, problems. So how to increase the VMC? Max power.
Power.
And how about the propeller?
Windmill.
Windmilling.
More drag.
More drag, right?
Yeah.
So in that prop, if you want to lower the VMC feather, if you want to show the VMC demo, max RPM, max prop, right? Takeoff configuration. That's why in the combat stuff, takeoff configuration. Why? Mixture full forward, from full forward, thrust full forward, more asymmetric thrust, more drag, then you will have the worst rudder authority. How about density? Remember, how the rudder works. The rudder can work because there is an airflow.
Yeah.
Okay? So, how to reduce the VMC? High density altitude, less air, less dense.
Oh,
Okay? What's gonna happen with that? Here, it's all about the temperature. Above standard temperature. Decrease. Why? The density will impact power. Because if you fly high, less dense, the power slow weaker. When the power weaker, less asymmetric thrust.
Yeah.
And what's gonna happen is,
That's 140.3
how about the VMC?
PMC will decrease.
Decrease. Okay? Now, if the density is all about the density, okay, temperature is standard, 50 degrees. What happened? Engine performance good, right?
Yeah.
When the engine performance good, what's gonna happen?
Higher
Thrust.
More and lower and higher VMC. That's why below standard temperature, VMC increase. Above standard temperature, decrease. Why? Because the cooler,
Dense.
the denser the air, the better engine performance, the higher asymmetric thrust, the higher VMC. So disconnected, both connected. Okay?
Yeah.
The other problem is if you fly high, more than the single engine surface ceiling, less dense, the rudder has no adequate airflow or air
Yeah.
to move. That's why you cannot fly higher. The weather is hot. Okay. Even that helps. The engine reduces performance. It means reduce VMC, but your rudder as well. You cannot get more adequate airflow to work for the yaw, right?
Yeah.
Good. Now we talk about drag device. Okay. To reduce the VMC, what do you need?
Like flaps.
Alright, so this is the airplane. with the engine, okay? Let's talk about the critical engine, right? The drag device, if you want to show that the VMC will getting higher, that will be on the takeoff configuration. Landing gear retract, flaps up. There is no help. If you put it down, flaps here, and you have gear, what happened, let's say this engine is out, or no, let's say this engine out, okay?
Okay.
Where's the left turning tendency? The P factor is going this way, right?
Left.
Asymmetric thrust. So you need to overcome by applying right rudder. How many pounds?
150.
150 pounds. Roughly like that. So it's like this. If you put the drag here, it's like an adverse yaw. So that will help you to overcome because the drag will give like a back forward.
Induce.
Yeah. If you put the drag, there is a drag demo, the landing gear, full flaps, you have minus 275 feet per minute, with milling propeller, 200 feet per minute, gear extended. No, I don't think this is correct. We need to see the book. Because if you put a gear down and the flaps down, okay, the VSI could be 900 feet per minute. This depends on the airplane. I don't know where the airplane comes from. We'll need to fix that. But and a half is
Descending. Right.
you will get descending airplane like very deep vertical speed per minute. You sink like that. Okay. So all of the dead prop we already talked before. You want to lower the VMC.
Yeah.
You feather
Feather.
higher VMC with milling. And how about the critical engine? Of course. If you want to lower the VMC critical engine on, higher VMC off. So on your VMC demo, the examiner will idle the left engine and you do the drill, engine fail, maintain directional control, mixture, prop, throttle, full forward, flaps up, gear up, identify left engine die, verify throttle close, prop close, there's no adequate altitude, feather, right? Close the mixture, okay?
Yeah.
On the left, because you already verified it. How to feather, close the mixture, and read the checklist. Fuel pump, fuel selector off,
Cold flap.
mixture off, cold flaps, right? And then what else?
Left alternator.
Fuel pumps off, left alternator off, magnetos off. Repeat that. So, mixture, prop, full forward, flaps up, gear up, identify left engine down, okay, verify, close, left throttle,
Left prop.
left prop,
Mixture.
mixture cut off,
Mixture off.
okay, and cut all the fuel lines, selector off,
Fuel selector off. Cold flap.
fuel pump off,
Fuel pump off.
alternator off, left,
Left
magnetos off, then feather,
Feather.
okay. After you feather, that's on the real situation, okay, real situation. But on the VMC demo, they will give you
Windmill.
simulated. So windmilling, even worse, right?
Yeah.
Even worse. You are not
Zero
feathering the
thrust.
prop.
Zero thrust.
So just zero thrust, maximum prop, okay,
Yeah.
and then takeoff trim, stuff like that, flaps up, gear up, because we don't want any drag to help to compensate that P factor on the left engine.
Mhm.
Then what else? Then you pull the yoke
knot per
one
second.
what?
1 knot per second.
1 knots per second.
Yeah.
Okay, slowly
Till
until
touch
it's
red line.
red line, and you will feel there's an induced
Induce
leave,
Yeah.
induced airflow of the right engine. Lift your right wing like that. So what are you gonna do? Close both throttle, nose down. Speed is gaining up, and
Increase the
increase the power. How to increase the power?
Slowly.
slowly
Increase the left
Left
engine
engine
first.
first.
Why?
to warm up the engine.
To
first.
warm up the engine because the cylinder head temperature will be cool, right? And then you're gonna open the cold flaps. Close first, and then when it's hotter, then open the cold flaps. So first, like this, idle,
Mm.
left engine first. Remember, now your right engine is that. When you increase the left throttle, left rudder, right? Maybe 1 minute. How to increase the right engine thrust?
Slowly.
Slowly reduce the left, increase the right.
Mm.
Make it equal, just don't do that.
Mm.
Reduce, meet in the center, and hold that. Then you get the engine back.
Mm.
So understand all the VNC stuff? Why do we care about the VNC demo? Because we want to know how
recover.
we can recover in adverse condition, worse condition, when the VNC increase, okay, to that configuration. But as a pilot, what do we want to do with the VNC?
Low.
Lowering the VNC, and how to lowering that? Remember this. Understand?
Yes.
Alright, guys, that's the VMC explanation about the multi-engine, critical engine, and then that will help you to prepare yourself for the check ride. Thank you for watching. Join 40 Day Pilot Flight Academy for the commercial multi-engine preparation check ride. See ya.